Okay, programming 11. We are now going to do something with these arrays. Right now we've just sort of made an array, which is like a book of numbers in our case. You can make different kinds of arrays, but these are arrays of ints. It's kind of like a book of ints, and has 3 different pages according to this piece of code here, and we can record numbers on each page. We can give the page number starting with 0 and record a number on there, and then we can flip the page to page 1 or page 2 and record different numbers all in the same variable. It's just got sort of different sections to store different numbers in it. So it was a reasonable start to what we did in the last video. We learned the nitty-gritty details of making an array of ints and assigning values. But now it's time to see it actually, like, where the value comes from. Like, why are we doing this? And the value is not really going to become apparent as long as this is 3. It's still not going to be great, but we're going to crank this up to be higher as we go. And we'll really see it by the end of this lesson, I hope. So we'll start off with now drawing these bricks. So in the last video, if you didn't see it, go watch it. We made the coordinates for some bricks in these arrays, and now we actually want to go draw it. So in my game function here, I have my paddle code, I have my ball code, here's my ball bouncing code, and now at the bottom of it, I'm going to put my brick code. So we'll just start off with just basic drawing of like 3 circles, right? So it'll be circle, and then how do I draw the first ball? Well, we're going to look in the X array on page 0 for the X coordinate for the first brick. And the Y coordinate is stored in the Y array on page 0 as well. And then brick diameter is just the size of it. And we can do this 2 more times. We can go for the second brick, we can do page 1, and for the third brick, we can do page 2. And this will actually work. It's not the final way we're going to do it, though, but it is going to work. I guess we'll see if it works. I'll run it. So do we see some bricks? Yeah, there they are. 1, 2, 3 bricks. They don't bounce yet or anything like that, but they show up. So this is this proves that the coordinates work, and you can store those things in the book. However, there is still an issue, and that is, like, what if I wanted to have 100 bricks? Like, that still sucks. Like, I still have to copy and paste this 100 times. No fun, right? No fun. We want to make this automated. We want to make this, lazy, really, so that we don't have to do so much work. So here's the deal. Instead of copying and pasting this over and over again and changing this page number manually, we can write a while loop that will change the page for us. I'll show you what the while loop will look like. I'm going to comment this out. And just below it, I'm going to put in a while loop. The while loop is going to start at 0 and count 1 and then 2 and then stop. So I'm going to make it int I equals 0 while loop, while I is less than 3 in our case. We're going to count up by 1. I equals I plus 1. So this while loop will have this I variable start at 0. 0 is less than 3, so it'll do its stuff. Then it'll go to 1. And then it will say 1 is less than 3. Good. We'll do whatever the stuff is. And then we'll go to 2. Then 2 is less than 3, so it'll do its stuff. And then I will go to 3. And then it'll go back and check, and 3 is not less than 3, so it will stop. So I will get 0, 1, 2. And then what we can do is we can take that, copy it, paste it, and then instead of drawing the brick on page 0, we'll draw the brick on page I. That's the key right here. That's the most essential thing right there. Because I, from one run of the loop to the next, changes from 0 to 1 to 2. And it all does this within 1 frame. It'll run this loop a whole bunch of times within 1 frame. So let's run it and see that we still get 3 bricks with a loop. And I can still see if you're skeptical, because you might be like, that's 3 lines of code, Mr. Pelche. That's 4 lines of code, 5 if you count the brace. What's the big advantage? Well, if you had 100 bricks, just imagine this. If you had 100 bricks, this code, you'd have to have 100 of these, right? 100 circle. If I had 100 bricks and I'm using this code, though, I can just change that number to 100, and it would draw all 100 bricks. So this code here is scalable. It can grow with the number of bricks and not really require you to do any extra work. I'll show you what I mean. I'm going to put this back to 3, And what I'll do is I'll actually go and increase the size of our array. And I'll add in a fourth brick. So I'm going to go over here, and I'm going to say, actually, I want there to be 4 bricks. And then I'm going to put in a fourth brick. I'll just copy and paste this. This will be brick number 3, kind of odd number for the fourth brick, but there it is. And I'll put it like that. And then in my game, I just got to make sure I go to 4 bricks. And this while loop didn't grow, but we now have a fourth brick. So that's pretty special. I mean, you may or may not see that advantage, but I hope that you can see that this kind of allows us to be pretty lazy. We can not have to do any more code to draw more bricks. And I'll also mention that we have to change this 4 in a bunch of places. That's going to make we're going to make a mistake on that eventually. So right now, let's go change that. Let's change that. Instead of calling that just 4, 4, 4, let's make a variable. I'm going to go to the very top. Oh, I already have it here. Int n. Don't worry about typing these out. We're going to do those in a separate lesson. But int n is going to be our variable to keep track of how many bricks I want. So I'm going to set n to be, say, 4, for example. And then I can change it here, and here, and here. And if I do those things, then whenever I want to add another brick, I can just change this number right here, and it will change in all the places I need it to change. Or put 100 here, or whatever I need to do. So that's us making it draw now, and making a loop that automates the drawing. Hey, while we have this loop here, let's also demonstrate the power of this by showing you that we're not just drawing the circles, we're also doing the bounce code, right? So the bounce code right now doesn't work. There's no code to bounce off of the bricks. But let me go show you how that could work. So I basically just need to use the same code as bouncing off a paddle, right? This code is very similar, except I need to change the paddle components so that they're referring to a brick. So I'm going to copy and paste this down here. I'm going to bring it down to just below my while loop. I'm going to paste that in, and I'm going to change this to be for a brick. Let's choose brick number 1, the second brick. So I can replace all the paddle code with brick on page 1. So brick 1, brick y1, and this would be brick diameter. The comment would be for brick collisions. And px is now x1 and y1, sorry, y1. So now that's bouncing off a brick on the page 1, the second brick basically. So if I run this, we'll see that the collision will work with that brick. It's going to be this middle brick here. I'll just get it to bounce off. We'll see. Yeah, it bounced off. I'm going to now show you that it doesn't work for the other ones. If I can hit them, I don't know. Let's see. Oh, I love this game. I'm so good at this game. No. See, it went straight through, right? It didn't work. Didn't work. It works for this brick only. I can't hit this brick to save my life. But it doesn't work for any of the other bricks. So again, you might be like, okay, I guess I got to go cut and paste this. But that's going to get so painful for 50 bricks or 1,000 bricks or whatever it is, right? That's a real bummer if you have to like copy and paste this over and over again. But guess what? We can put that in the loop too. We can put this in the same loop, and we can change this instead of one particular brick, we could change it to I, so that our while loop will first check brick 0, and then it will flip the page to brick 1, and then we'll flip the page again to brick 2, and so on. So if I cut and paste this and put it, I'm going to put it right here, right after circle, right before I equals I plus 1. If I put it right here, I'll press Control T to auto indent. Then, because I've got all these set to I, and I is changing in this while loop that happens all in one frame, then all my bricks will now become, physical. They'll be like solid. Like this brick, I can't hit a brick. Just can't do it. Can I hit him? Can I hit a brick? So it looks like I'll hit this brick. Yeah. And then will this brick hit? Yeah. See? All the bricks are now tangible, solid things that have collisions, because this while loop here is running every time, checking every single brick in all the pages. I can't seem to hit other bricks other than these two, but I assure you they're all working. See that? No, nice. Anyways, it works really nicely. So here's another reason why using these loops is fantastic. It saves me, from doing this 50 times and doing this 50 times if I had 50 bricks. It just works for however many bricks. And if I wanted 1,000,000 bricks, this could change to 1,000,000, and I wouldn't have to add any more code to this. This would work for 1,000,000 bricks. So hey, there we go. We just automated our collision code for many, many different objects. There is still another lesson, and that's going to be laying out a pattern of the bricks. And I think that lesson is really important. So we're going to stop this lesson, and then we're going to see how can we turn this into a loop. I think that'll be really useful. Okay, thanks everybody.